What if you want to modify a value in the list? Well, that's really straightforward, as it turns out. So again, we've got this range 5, 6, 7, 8, 9. So if we want to access a value in some list, we could do that like this, right? Print some list sub 0. And we're going to see 5. If we want to modify this, we can just assign a new value to this. So let's call this elephant. So the first element of some list is going to get changed to elephant. And of course, we're not going to see that unless I print it. So let me print some list again. I'll just copy this from up here. And what we're going to see is elephant 6, 7, 8, 9. So that should be pretty straightforward, right? And the implication here is that lists are what we call mutable. Now, that sort of makes sense, right? Because it's a collection, and we might want to add to the collection or take away from the collection. And in general, collections are mutable. There is an immutable collection called a tuple, and that just means that when you change a tuple or you take the values in a tuple and you put them in another tuple, you destroy the original object. So maybe to give some other sense of this, if you recall the ID function, ID just gives us, let's say, a location in memory for the object. And when we looked at scalar types, like ints, floats, etc., if we changed the value that the variable pointed at, it would change the location in memory. It would change the ID. But now we're changing this list. We are changing it, right? We're changing a value in the list. However, the ID does not change. And you might think of this as being, you might think of a list as being a collection of pointers to objects. And those pointers are stored somewhere in memory. And the list itself isn't changing, right? What is contained in the list changes, but the list itself doesn't change. So that would give us a consistent memory location for that list, as we can see here on the right.